Alright, here are the solutions of homework topic 8a. Okay, first question, the angles of quadrilateral are x, 3x minus 10 degrees, 27 degrees, and 4x minus 30 degrees. Find the measure of the largest angle of the quadrilateral. So we know the sum of all the angles in a quadrilateral is 360 degrees, right? Therefore, we know x plus 3x minus 10, then plus 27, and plus 4x minus 30 should equal 360, right? This is a property of any quadrilateral. Therefore, we got a equation in terms of x, which basically means you have 8x minus 10 plus 27 minus 30 equals 360. And we can solve x is actually 373 over 8, right? Which is 46.625, and the unit is degrees. And therefore, the angles of the quadrilateral are x equals 46.625, and 3x minus 10 gives us 129.875 degrees. Then next angle is 37 degrees, and last one is 4x minus 30, right? Which is 156.5. Therefore, we know the largest angle of the quadrilateral is the last one, 56.5 degrees, right? Any questions? Alright, then next one. In trapezoid ABCD, AB is parallel to CD. Diagonals BD and AC meet at point N. And set lengths BN, CN, DN, and CD are as shown in the diagram. Find AN and AB. Okay, so parallel lines means similar triangles, right? So from AB is parallel to CD, we have triangle ABN must be similar to triangle CDN, right? Therefore, we have AN over CN should equal BN over DN, which also equals AB over CD, right? And since we have BN over DN equals 1 over 4, then all of these fractions equals 1 over 4. Therefore, we know AN equals CN over 4, which is 3. And of course, AB is also CD over 4, which is 5, right? You get this correctly? Any questions? Okay, if not, let's see the next one. In quadrilateral PQRS, PQ is parallel to RS. PS is not parallel to QR. QR equals PS, and angle P is given, which is 83 degrees. Find the rest of the angles of the trapezoid. Okay, since the legs of the trapezoid are equal, the trapezoid is isosceles, right? This is a property of the trapezoid. And therefore, we have angle Q must equal angle P, right? Which equals 83 degrees. And because we also have PQ is parallel to RS, then we have angle S must equal 180 degrees minus angle P, which is 97 degrees, right? And similarly, angle R is a supplement of Q, which is also 97 degrees. Again, if you're not familiar with the setup of a trapezoid, you can draw a diagram to help you think. PQRS is a trapezoid like this, right? QR equals PS. Therefore, this angle equals this angle, and this angle equals this angle here. Oh, sorry. It says angle P is a acute angle, so P is not here. P should be here. Okay, any questions? Alright, then let's see question number 4. The area of a trapezoid ABCD is 96. One base is 6 units longer than the other, and the height of the trapezoid is 8. Find the length of the shorter base. Okay, we can let the length of the shorter base be x. Because this is a desired length. So if you let the length of the shorter base be x, then the longer base must be x plus 6, right? And the area is 96, then we have the area equals 1/2 of x plus 6, right? Sum of the two bases times the height, right? Which equals 96. Therefore, we know 2x plus 6 equals 24, and x must equal 9, right? And therefore, we know the length of the shorter base is 9. Okay, any questions? Okay, if not, let's have a look at the next one. Question number 5. ABCD shown at right is a trapezoid with BC is parallel to AD, angle ABD is 88 degrees, angle A is 72 degrees, angle C is 126 degrees, and it asks you to find angle ADC and angle CBD. Okay, so we have a pair of parallel lines, which is BC parallel to AD. Then we have angle ADC must equal 180 degrees minus angle C, or BCD, right? And then that's 180 degrees minus angle C, which is 126 degrees, and this gives you 54 degrees. That's angle ADC, right? And similarly, we have angle ABC equals 180 degrees minus angle BAD, and that's 180 degrees minus 72 degrees, which equals 108 degrees. And therefore, the desired angle CBD should equal angle ABC minus angle ABD, which is 108 degrees minus 88 degrees, which is given, and that is 20 degrees, right? Any questions? So the correct answer are 54 for ADC and 20 degrees for CBD. Alright, then next one. Question number 6. Diagonals of a convex quadrilateral ABCD meet at E. Prove that the centers of the circumcircles of angle ABE, BCE, CDE, and DAE are the vertices of a parallelogram. Okay, let's draw a arbitrary quadrilateral first. Okay, A, B, C, D is a convex quadrilateral, and the diagonals AC and BD intersect at point E. Okay, so basically we can let the circumcenters of triangle ABE, triangle BCE, triangle CDE, and triangle DAE be, let's use some letters to denote the circumcenters of these triangles, P, Q, R, S respectively. So P lies on the perpendicular bisector of side BE. Of triangle ABE, right? Because this is a property of the circumcenter, right? And we also know that Q lies on the perpendicular bisector of side BE of triangle BCE, right? You follow me? And therefore we know PQ, segment PQ, is perpendicular to line BD. Right? And similarly, RS, line RS, is also perpendicular to line BD. And therefore we know if RS is perpendicular to BD, PQ is also perpendicular to BD. We know that PQ must be parallel to RS, right? And similarly, you can use the same method. We have QR is perpendicular to AC, and SP is also perpendicular to AC. And therefore we know QR must be perpendicular, must be parallel to, sorry, there's a typo here, this should be parallel. And we know QR must be parallel to SP, right? So then we know two pairs of the opposite sides are parallel with each other. Therefore, we know the quadrilateral PQRS is a parallelogram, right? Did you get it? Any questions? Have a look at the solution here. All right, if not, let's have a look at the next one. Okay, the bases of a trapezoid have lengths 50 and 75. Its diagonals have lengths 35 and 120. Find the area of the trapezoid. Alright, let's have a look at the solution together. So we can let the trapezoid be ABCD with AB is parallel to CD as shown in the diagram. Let's first draw the diagram, okay? So the trapezoid should look like this. So AB is a shorter one, and let CD be the longer one. Okay, so let's call this point is A, B, and then C, D, and they meet at E here. Okay, so AB is parallel to CD, and AB equals 50, and CD equals 75, right? These are the two bases, and let the diagonals meet at E. Since AB is parallel to CD, we have okay, let's write it here. Angle ABD is actually equal to angle BDC, right? And also we have angle BAC equals angle ACD. Therefore, we have triangle AEB is similar to triangle CED, right? So we have EC over AE equals DE over EB, which equals DC over AB, which gives us 75 over 50, which is 3 over 2, right? Can you follow me? So if we let BD be the shorter diagonal, as shown here in the diagram, and AC be the longer one, we have PE plus ED is 35, and AE plus EC is 120, right? Since we also have DE equals 3 over 2 times EB, and EC equals 3 over 2 times AE, which is proved here, right? Then we can solve BE plus 3 over 2 VE equals 35. And that gives us BE is actually 14. And similarly, we have AE plus 3 over 2 AE equals 120. Therefore, we know AE must equal 48. Right? And we know that the size of AEB, so note that size of triangle AEB has a ratio of 7, 24, 25. Then according to Pythagorean theorem, this is actually a right triangle, right? It's a right triangle. Which is angle AEB is actually 90 degrees, right? Because AB is the longest side of the triangle. Longest side is hypotenuse, which corresponds to the right angle there. Also, you could use the Pythagorean theorem to determine that triangle AB is a right triangle. You don't have to use the ratio, right? So anyway, we are here. We know that angle is a right angle, and therefore we can dissect ABCD into 4 right triangles. Which are triangle AEB, triangle BEC, triangle CED, and triangle DEA respectively. And since AE is 48, and we also know BE is 14, right? We have CE equals AC minus AE, which is 72, and DE equals DB minus BE, which is 21, right? Therefore, we have the following conclusions. We can then find the area of the 4 little triangles. So triangle AEB, the area of triangle AEB is 1/2 of AE times EB, which is 336, right? And then BEC is 1/2 times BE times EC, which is 504. An area of triangle CED is 1/2 of CE times ED, which is 756. And similarly, triangle DEA, its area is 1/2 of DE times EA, which is 504. Therefore, we know the area of quadrilateral ABCD, or actually trapezoid ABCD, is the sum of all these areas, right? Which gives us 2100. Okay, did you get it? Okay, have a look at the solution here. Any questions, just let me know, okay? So the key is to prove that angle AEB is a right angle there. All right, then if no questions, let's have a look at next one. Okay, question 8. In the diagram, ABCD is a parallelogram, and E is on the extension of BC past C. AE and CD meet at F, given the area of ADF equals 64, and the area of CEF is 4. Determine the following. A, CF over DF, B, the area of BFC, and C, the area of ABCD. Okay, so let's have a look at the first one. We know that DA is parallel to BC, right? Therefore, we have angle ADF equals angle ECF, and angle DAF equals angle CEF, right? This is what parallel lines tells us. Therefore, we know triangle AFD is similar to triangle EFC by AA similarity, right? Okay, then because we know the area of AFD over the area of EFC is 64 over 4, which is 16 over 1, right? Then their corresponding sides are in a ratio of square root of it, right? Therefore, we know CF DF over CF is the square root of the ratio of the areas, which is 4 over 1, right? Therefore, we know CF over DF must be 1 over 4, right? Okay, then question B. We want to find the area of triangle BFC. Okay, since AB is parallel to CD, then the distance from point A and B to CD are equal, right? Therefore, we know triangle BFC and triangle ADF have equal altitudes or heights, right? But their bases are in a ratio of CF over DF, which is 1 over 4, right? Therefore, we know the area of BFC must equal 1 over 4 times the area of ADF, right? Which is 16. You get it? Okay, last question. Okay, last question. We can draw some auxiliary lines. So we could let G be the point on AB such that AD is parallel to FG and parallel to BC. So you should write it like this. You could let G be the point on segment AB such that AD is parallel to FG, which is parallel to BC as well. Then triangle ADF is half of the parallelogram. Can you see that? ADF is half of the parallelogram AGFD. because this is a diagonal of the parallelogram ADFG, right? And therefore we know the area of AGFD must be twice of the area ADF, which is 128, right? And similarly, we have triangle. The area of triangle BFC is half of the parallelogram on the other side, GBCF. BFC is here, is half of GBCF. And therefore we have the area of GBCF is twice of the area of BFC, which is 32, right? Therefore we know the area of ABCD is actually the area of AGFD plus the area of GBCF, right? AGFD is here. Plus GBCF, which is here, right? So that's 128 plus 32, which gives us 160. Did you get it? Okay, again, have a look at the solutions here. Any questions, just let me know, okay? Alright, if no questions, let's have a look at the next one. Number 9. Okay, it checks your understanding of the properties of rhombus. So, as we have learned, the area of a rhombus is half of the product of its diagonals, right? Hence, we know the area of PQRS is just 6 by 12 over 2. You can directly find the area of the rhombus, right? And the diagonals bisect each other and are perpendicular, thus cutting the rhombus into 4 right triangles with the legs 6 over 2 equals 3 and 12 over 2, which is 6, right? The hypotenuse of these triangles is square root of 3 squared plus 6 squared, right? Which is 3 square root 5. Therefore, we know the perimeter of the rhombus is 4 times the hypotenuse, which gives us 12 square root 5. Did you get it? Again, that checks your understanding of the properties of a rhombus. Quite straightforward, right? You have any questions? Alright, if not, let's have a look at question number 10. Again, a rhombus WXYZ with WX equals 50. Okay, let's draw a rhombus first. Okay, if WY equals 96, we know that's 48 here, right? And 48 here. So the diagonals bisect each other, cutting the rhombus into 4 right triangles of hypotenuse WX equals 50, and one leg is 48 here, right? Then the other leg, we can find the other leg. So let's call this point O. So the other leg OX equals square root of 50 squared minus 48 squared, which gives us square root of 196, which is 14, right? So this side is 14. Therefore, the diagonal XZ is twice of 14, which is 28, right? Okay, B, the area of this rhombus, WXYZ. Again, that's just the 1/2 of the product of the two diagonals, 96 and 28, which is 1344. And third question, find the distance between WX and YZ. Okay, you can also treat the rhombus as a trapezoid, right? We know that using the formula to calculate the area of a trapezoid, that actually is 1/2 of the sum of the two bases, which is 50 plus another 50 times the distance h. Oh, let's call distance d. Oh, sorry, let's just use h, which gives you 1344, right? And therefore we know h should equal 1344 over 50, right? Which is simplified to 672 over 25. Any questions? No? Alright, then let's consider the next one. Question number 11. TUVW is a rhombus. TU Okay, TUV is 60 degrees. So V must be here. And W is here. TUVW is a rhombus with TU is 10, TUV is 60 degrees. Okay, that's all the information we have. First one, show that angle TUW, okay, which is the angle here, is 30 degrees. Okay, we know that triangle TUW must be congruent with triangle VUW, right? Okay, I'm not gonna write all of the statements here. By SSS, right? Therefore, we know angle TUW must equal angle VUW, which equals 30 degrees, because these two angles combined makes 60 degrees, right? So each of them is 30 degrees. And for the second one, diagonal TV cuts the rhombus into two equilateral triangles of side 10, right? So side TV is also 10, this side is 10, and this side is 10, right? And we know that the area of this quadrilateral must be twice of the area of a triangle TUV, right? And we know how to find the area of a equilateral triangle, which is 10 squared square root 3 over 4. then use 2 times that value, which is 50 times square root 3, right? Can you follow me? Okay, have a look at the solution here. Any questions, just let me know, okay? And next one is actually very similar to question 11. It says one of the angles of rhombus is 120 degrees. So let's suppose this obtuse angle here is 120 degrees. And it says if a shorter diagonal is 2. If the shorter diagonal is 2, which means this one has length 2, right? Therefore we know this length is 1, this length is 1. And we also know this angle here is 60 degrees, right? And therefore we know we have one equilateral triangle here with set lengths 2, 2, and 2, right? And another equilateral triangle here with side lengths 2 as well, right? Therefore we know the rhombus, the area of the rhombus is twice of, again, 2 squared square root 3 over 4. Did you get it? So if you know the side lengths, you should be able to immediately write the area of that equilateral triangle, which is the squared set length times square root 3 over 4. Did you get it? And this gives us 2 square root 3, right? Any questions? Okay, and the next one also, the method should be similar. EFGH is a rhombus. EF equals EG. E must be here, right? EF G H. Okay, EF is 6, EG is also 6. Since EFGH is a rhombus, we have FG equals EF, right? And FG is also 6. Again, this rhombus consists of 2 equilateral triangles, right? So if you know the set length is 6, then we know triangle EFG, area of triangle EFG is 1/4 of 6 square root 3, right? Then the area of the rhombus EFGH must be twice of that equilateral triangle, which gives twice of 6 square root 3 over 4. And we know that 18 times square root 3, right? Any questions? No? Okay, have a look at these questions. If you have any questions, just let me know, okay? And if you don't have any questions, let's take a 10 minutes break. And after that, we'll have a look at the second part of topic 8, okay? All right, see you in 10 minutes.